up here a little bit closer. Okay, so 200 degrees of freedom is here. The column P of 0.01 gives us 2.345. Okay, so actually what we have is 2.345. The important thing to know here is this, is that as our degrees of freedom increase, okay, as our degrees of freedom increase, our critical values are getting smaller and smaller and smaller. So if anything, as this increases down, this is going to be smaller than what it is. In other words, it's not going to be further, it's actually going to be closer in to this particular center value here. But the important thing that we have here now is this, is that we have, from a distribution perspective, okay, 0, here's our critical value here, it's 2.345. There's our rejection region here, okay. And actually what we now know is this, is our test statistic is 6. So our test statistic t is equal to 6.00 is falling into the rejection region. Okay. In other words, if you think about it, what we're really saying here is this, is that the difference between the evidence that was observed for prime land, okay, and the evidence for rock land, okay, that the difference was 47,000 minus 44,000, yeah, the difference is actually 3,000, and that difference, and it's also positive, yeah, actually what we can actually see based on the evidence, the difference is positive, which means that the X bar for prime land is actually bigger than the X bar for rockland, if that makes sense. Okay, so it's actually positive. Okay, so and we're in the rejection region. So what we're really doing here is we're rejecting H0. We're going to reject H0 in favor of HA. Now what does HA actually says? HA says that the population mean for prime land is actually bigger than the population mean for rockland, which is what we wanted to show. So now our decision, step 5, is our decision. Okay. And what we're going to have here is this, is that clearly our test statistic is bigger than our critical value. And what I mean by that is 6.00 is bigger than 2.345. And as such, we reject H0 in favor of HA, at the 5%, no, at the 1%, isn't that right? It's at the 1% significance level, at the 1% level of significance, okay? And now, because we've rejected, we can actually infer, and we infer that average income for prime land is actually greater than average income for rockland. So, and infer that average income for prime land, and let me write this down here, hopefully you can see this, for prime land is bigger than mu of r, so it's bigger than, is higher, okay, than the average income for, than that of rockland, okay, of rockland, okay. So that's where we are there, okay. So that was actually our independent samples t-test done, okay. So you can actually see what we got is we got a situation where we rejected, okay. But let me just reflect back over this really quickly, okay. The important thing here was this, is that when we're given a scenario, what we should always try to do is to extract all the information out. Now, I extracted out two samples, two sets of information, one for one sample, one for another sample, okay? Also, I observed that the observations were either from prime land or they were from rockland, so that they were independent of each other, okay? There was nothing shared across them. Also, the significance level we could extract out, alpha is equal to 0.01. And because I had two samples, and the two samples were independent of each other, well then, what we actually were in the world of an independent samples t-test, okay. So just remember that's really important, is to take your time going through the scenario and to extract out as much information as possible. But ultimately, in this particular case here, we set the hypothesis. The scenario asked us to test at the 1% level of significance the proposition that the average household income in County Primeland is higher than in County Rockland. In other words, for us to test that particular proposition, we had to put it in as the alternative hypothesis. Okay, so here we go. That's all we can never do. Is what we want to test, we put into the alternative. That is that mu of PR, the population mean for Primeland, is bigger than the population mean for Rockland. Now, just keep an eye on this particular thing when we're putting these into our test statistics. I was just looking at some consequences of H0, okay? But now the consequence of H0 is that P of R minus R would actually be less than 0. The alternative, the consequence of the alternative, is that mu of PR minus mu of R is actually bigger than 0, which is what we observed. We observed that the difference between the evidence, was actually positive, if that makes sense. It was actually a positive value. So actually, we were in a right-hand tail test, okay? And our decision was our critical value was 2.345. Our test statistic was 6.00. Our test statistic has fallen inside the critical region, and as such, we'll reject H0. See, what this is really saying to us is that it's more than likely, things that happen in the tails are very, very unlikely, okay? But it's more than likely that we would have observed this. It's more than likely that we would have observed this if this distribution was actually over that particular test statistic. That would be more than likely going to happen than actually this scenario here. And that's obviously the part of the crux and the logic behind our hypothesis testing. Okay, guys, this was actually a long video there, okay, but it was a long scenario, long example. So once again, guys, this was Jonathan Lambert with the Mathematics Development and Support Service at the National College of Ireland, and I hope that this video was in some way intuitive, and more importantly, I hope that was helpful for you, and thank you for watching. Okay, bye bye.